All right, so at this stage, we've seen how we completed the trig calculator um, um, header file, which is really, for us, as far as we're concerned at this point, the initial prototype for this particular component. Okay, so it has its own menu. It's got its own functions that actually do the work, right? So we have an addition, subtraction, multiplication, division, power, and square root. And we have the logic for this component stored right here, okay? And then your application, basically, when it needs the arithmetic calculator, it calls upon it. Once you have an actual option that is valid for calling it, that is why the arithmetic operation is an extended case for the use case calculator as a system. Okay? So once it calls it, then it returns a result that we handle right here as an include use case to display the result. Okay? So now what we would like to do is have another component in another header file that handles this user feature. Okay? So you go back to your requirements and you read them carefully in terms of what does the user want. They want to be able to do sine and cosine. Good. They're not asking for tangents or cotangents. That's the scope of the work. So the scope of the work, what they want, and make sure that you specify exactly what they want and you are clear as to what they do not want. That way you don't end up with what we call scope creep. Scope creep happens is when you start designing things and then all of a sudden you're adding features that weren't part of the requirements or were not part of the vision for the user, and you start drifting, or you maybe while you're meeting with the client, after you've agreed on the scope of the job, suddenly the client is like, oh yeah, by the way, I would like to have cotangent. Well, that's great, we can do it, but it's a different project or a different cost. You're gonna have to negotiate. You have something to negotiate with. Versus if you just said yes, for the same cost you've done everything else, you're not using your time wisely, and some of these requests might be too complex once you delve into them. Because they might look like, oh, that's an easy fix, an easy addition. Do not overpromise. Do not promise things you haven't analyzed. It's better to listen carefully initially, make sure that you understand what the requirements are, make sure you communicate back with your client and make sure they understand that you're on target with the scope of the work. Should they want anything else, and you've already have some sort of a mechanism in place to be flexible. I'm not saying don't be flexible, but make sure that cost is included and the risk is included in that process, okay? Because you have to look at things from a risk analysis point of view. I mean, the more you take on, the riskier, the more risk you're going to be exposed to throughout the project. And in the end, it could be a detriment to specific aspects of your project or the whole project overall, and or your reputation, especially if you have other future work to do with that client. So make sure you don't fall for that trap. So really tread lightly when it comes to that, okay? So what do we want? We want a trig calculator. So from a component point of view, we've agreed that we're going to create another header file that will just do that. And then we're going to call it here, okay? And we're going to call it a trig operation, the function that, so we're going to need some logical function within that header file called trig operation, similar to how we did the design for the arithmetic calculator, okay? So let's go back to the arithmetic calculator. I had a point of entry function right here called arithmetic operations that called its own subfunctions like addition, subtraction, multiplication, etc. So we're going to use the same technique, same strategy for designing our trig calculator. Okay? All right, so let's go ahead and create. So I'm going to click here, source file. It's going to ask me, do you want this to be part of the project? The answer is absolutely. And this here will be called trig, or if you want, you can spell out the whole word trigonometry or trigonometric calculator or whatever it is. So trig.h for me. All right, as you can see, I'm already having trouble voicing it out. Okay, so trig.h is fine for me. That's what it will be called. And so what kind of functions are you going to need? Well, definitely some sort of a submenu that is specific to a trig calculator. Definitely some trig functions. And then definitely some sort of a control function that allows you to enter in here and use these functions, right? So maybe something like this, int menu or trig menu. Now let me see what I called my menu here. I called it arithmetic menu. Call it trig menu. Stay consistent. So trig menu. And remember, we only want sine and cosine. That is the scope of the work. Can we expand on it? Absolutely. Can it be done? Yes, based on the fact that we're designing modularly and in component, using component-based software engineering, we can do that sort of thing. Heck, we can take this trig.h and use it in another project. That's the beauty of separating them in these header files instead of writing them all within the application. What do I mean by writing them all? All these function definitions. I am storing them right here in these header files. So in this one here, int choice, you can pretty much predict now my style here. So we want, just to make sure, include CMath, so I don't forget. And, oops, wrong symbol here. And then make sure you're using namespace std here. So that way we know we could use cout and cin right here if needed. Okay. So in a way, it's almost like a separate program without the controlling function main, because it's not really an application. It's a header file. You can't run it by itself. You're going to need an application to use it. So think of it as a helper file. Okay. All right. So cout /t trig calculator /n and list here what you want in terms of your menu items. Notice no semicolons here. This is the /n is an escape character. /t is also an escape character. So /t gives you a tab. /n gives you a hard carriage, right? So one cosine of an angle /n and /t 2 sine of an angle. No tangents, no cotangents, unless later on you agree with the user or the product owner. What is it you want to do? Okay. Let me look at my menu here. So it was a single /t for the choice. Enter, oops, /t here. So it's a little offset. Enter your choice. And notice that's a semicolon because I want the prompt to blink right here. And then I will do a cin choice and then simply return choice. Now, in a real application, I'll do a little more than this. I will go ahead and validate and make sure that whatever you're doing is within 1 and 2, and then return a valid value. to whoever calls trig menu. Okay? That's extremely important. Okay? But right now, remember, we're doing prototypes. So everything, all my designs are prototype. Oh, by the way, I didn't save this file, so let's go ahead and do that. This would be a .h file, by the way. And I'm going to call it trig, just like that. Trig. Okay? Excellent. So I need a controlling function that will call this menu. And then we'll do the functions that, so for example, just like the controlling function that I had here, arithmetic operation, I'm going to have trig operation that returns a double. Basically, it returns the result, right? So maybe something like this, double trig operation. Okay. And it will simply, so I'm going to need double result. By the time we're done, return result. So notice it's gutted right now. There's nothing really in it. I am just setting up the framework of what I want. And then here I am going to need double. Now, if I say cosine, since I'm going to use the math libraries here, you know what? I am not going to define user defined functions. I'm going to go ahead and straight use cosine and sine right here based on my choices. So I'm going to need int option, for example, and then, or you could do this, equals trig menu. Go ahead and assign it the value, call trig menu, and assign it to option. And then have either a case or I prefer a case in case you add more operations. It's much better than an if statement or a nested if statement. Okay, I will keep a nested if statement in the application since I only have two choices. You're either going to have the trig calculator or the arithmetic. Here you might have more operations eventually. The client, as I said, might ask for more features than just cosine and sine. Time permitting, cost permitting, you can do that. It will take you a few minutes to complete for this particular project. On real projects, we are, let me be frank, even as software engineers, we're really bad at time estimation and or cost. Unless you break down everything to the details and you really think hard about how much time is really actually spent on any task. Okay? There are a few techniques you could use. I mentioned something where you could use your own experience to a certain point. You could prototype and so on to figure out how long does it take. Or if you have a pattern and you've already done something similar, then it will give you an idea how much time you would do it. But don't count on things being linear. Okay? All right. So, however, in project engineering, you will notice that the progression for your whole project as you move forward is actually not linear. Even if you're doing the same thing over and over. It's actually exponential. And the reason is because you've learned a lot throughout that process where things get much more efficient and faster. That's if you know what you're doing. Okay? All right. So let's do a case here. And based on option, let's open curly brace, close curly brace. And basically, case 1, you're going to ask the user, see out, enter an angle in degrees. Now, I am saying this in degrees because that was part of the requirement. It wasn't in radians. Right? So you're going to have to convert it to radians. Aha. So we need a function right here, double, and then 2 radians. And it will take a double, num, whatever it is, and double rad for now, and I know I'm going to return that. Return rad. That's the angle in radians. By the way, if you want to be more descriptive, you could say this is degrees. Okay, so this would be degrees, and in the end, you're going to return a rad. Okay, right? Or you could say angle in degrees, angle in radians. We're going to do the process here, or the conversion. So we're going to call this function as an interim function for us. So we're going to do a cin here. And that would be the angle. So you're going to need an angle right here. So cin angle. And your angle is in degrees right now. So guess what you're going to be doing? The actual angle will be equals to radian and then pass the angle. Aha! This is a neat little trick where you can pass the angle in degrees and reassign it to angles in radians once you've done the process of conversion. And I'll show you how to convert from degrees to radians in a minute. Okay? It's a simple algorithm. And but this is the key here. So we need this transitional process to make sure that we convert the angle into radians, right? Using the 2radians function that we designed. We're going to be designing in a minute. So what's going to happen now is you can actually return cosine. This is why I chose not to use the cosine, my own cosine function. Use one that already, what we call it cots, already exist. Angle. Return, or you could say, you could return or get out, or simply say result equals, and then you can return at the end when you're done. You could do this. Okay? Because if you hit return, you're out of this function, you're back in main. This here gives me a chance to exit gracefully. So I don't like multiple return statements within a function. You can. But, try to be a little more formal. Make sure you go through the break, maybe, or something of that nature, just so you can hand over stack operations properly. So case 2, we're going to do the same thing. And then cout. Enter the angle in degrees. And then put a semicolon here. Before I said an angle, I'm just going to stay consistent, an angle, and then cin the angle. And then the angle itself will be equal to 2radians. One word, that's a function name. And supply it with the initial value of angle in degrees, obviously. And it will be returned. So the result for this will be equal to sine, the function sine that is in CMath library, and supply it the angle. And then break. Now, default, we have nothing else, which means we're not doing cosine, we're not doing, we're not doing cotangent or tangent. There are no other choice other than 1, 2. So if you type anything else, you could print an error message. No such trig option. And you're done. Okay? So that will be the default statement you would want right there, because you only need a couple things, sine and cosine. Okay? So sine is 2. Let me make sure I got this right. I made cosine first, yes, and as 1, and sine as 2. Okay, so now the conversion. let's do a quick analysis for the conversion. Pi is in radians. 1 pi is 180 degrees. So let me show you here. So if you have 180 degrees, gives you pi, right? So I'm just writing here as a scratch pad to show you how to do something. So if I have, let's say, n degrees, and you're looking for x in radians, then x will be equal to n times pi, and then the whole thing divided by 180. So you cross multiply pi and n, and you divide by 180 to find x. This is what we call rule of 3. Okay? Règle de 3 in French. So how do you work this? I'm sorry, 180 here. So in our case, let's go ahead and do a const double pi equals 3.14. All right, so we got that. 180 is already constant, so I have pi. N is in degrees. Okay, so let's go ahead and redo the formula here. And this would be degrees, and this would be rad. Here you go. So the angle in radians, right, will be equal to your angle in degrees times pi divided by 180. Put a semicolon. That's how you solve for this algorithm here. Now that you might find yourself spending an hour or two working on much more complex algorithms out there in real world, right? So what's going to happen is, prior to this, you should have planned for that kind of work as a task. Should have given it a priority, some sort of measurement in terms of cost, time, whatever is associated to it, including human resources in terms of who's the expert in this area. And so that way you can assign the proper personnel for the proper solutions for some of these algorithms. So I think I got this here, and that should do it. Let me just compile this part, or rebuild all, just to make sure everything is good. Now I need to include trig.h in my application. Notice I don't have it, so I need to include it here. Otherwise, it's not linked into it. Include trig.h. And now let's go ahead and link everything and see if we get an error. And everything looks good. So now let's go ahead and try to prototype this. So what do we need to do? So here, else, if option is equal to, go ahead and do result equal trig operation. And there you have it. So that means you're going to the controlling function for trig.h, which is this one. That's your point of entry. Once you're in here, you're going to call a menu or a submenu for the trig menu, right? You're going to pick either sine or cosine. So whatever you pick, let's say you picked cosine, well, you're going to be asked to enter an angle. Then that angle will automatically here be converted to radians, and then it will store the result after it processes that angle in radians and stores it in result. And once you get out of there, it will return result back to here. And then whatever you print here will be the result of this operation. Now let's see how this works. So I'm going to compile and run. And we're going to pick the trig calculator. And notice it's going to clear the screen for us, because we've already, from last lesson, included the system CLS, the system pause where we needed to. Makes life a lot easier here when we're ready to do things. Let's do a cosine. So yeah, so let's do a cosine of 45 degrees, right? So we know cosine and sine of 45 degrees will be the same, right? So here you go, 0.707. And let's do it again. So we're going to pick now 2 for trig. And let's do a sine. Okay, so again, 45 degrees. And sure enough, we get the same result. Let's go ahead and do for 90 degrees. So 2. And we're going to do cosine for 90 degrees. Okay, we get almost 0. Now remember, I didn't put anything in here to round things, so it's a 0. Okay, effectively speaking. So the next version, you need to go back in there and round the output to at least a decimal or two to make sure that you're seeing a 0 right here. Let's do sine 90 degrees, and we should get 1. So 2 sine, 2 is for sine, and we're going to do 90 degrees. And there you have it. Okay, so let's do the trig again, and let's pick something that's not on the menu, like 8. No such option. And notice we get some fictitious value for a result. We can fix that later on, because you are returning something. You didn't even do any calculation. You just returned whatever garbage was in result. Okay, so again, we can fix and clean things up as we move forward. But right now, this is simply a prototype, just to make sure that we've set up all the framework for how this is going to work. We've identified all the components that we're going to need. We've implemented them. We know they can communicate to each other. They can talk to each other. So let me just go ahead and do a 3 exit. And let me go to the directory. Notice now this is my project. These are the files for the project, right? And notice running this application, really, all you need to do is run the executable, which is the application right here, right? So if I double click here, that's going to run my project. That's what you submit or sell as an application, right? So this here will be simply the .exe file. Let me just hit 3 here because I know it works. But the rest are supporting file for the source code. So let me close my Dev C++ or my IDE and go back to here where it says arithmetic and open the .dev file. I'm sorry, .dev is the mauve one here. So if the .dev will open the whole project. So watch this. And then you can go back and update and make changes. Here you go. So now you have all 3 files that are needed. So if you click here, that's your application, but it needs these 2 header files, right? And by the way, we don't necessarily need CMath here because they are supported already under trig and arithmetic.h. They already use CMath. So it's redundant, but again, it's a matter of later on go and clean up some lines of the code and so on and so forth. But right now, I hope this tour here gave you a good idea on how to write code that will be eventually transportable. And what do I mean by that? Now, let's suppose your user comes back a year from now and says, that was great. The calculator here, can you add another feature? Or we don't want these 2, or I want the arithmetic and trig to be in another application. You say, yeah, no problem. The trig is already pre-canned in here. I can always include it in another application. I can always include this in another application. If you want more features, we can create another header file and then add an extra line here and go from there. Okay? So you have full control over versioning for future updates of this program. And that's the point here, is to be as efficient as possible. And like I mentioned before, your progress is going to be exponential, not linear as you move forward. And that's because you've learned a lot through the design process. what works and what doesn't, and how things fit together. You're going to waste a lot less time trying to fit things together, and you're going to get a better outcome and faster outcome. The next project is going to be a lot better because you're going to learn how to estimate even better. Okay? All right, so on that, I hope to conclude functions with this lesson. The next video will be about arrays, and then after that, we're going to be going to the dreaded pointers. And then with pointers, we're going to go back to functions and arrays and play with those concepts to make sure we can thread it all together and finish up our introduction to C++ with structure or struct. After that, after the series of introduction to C++, we will have another series of C++ OOP, or object-oriented programming.